Hi, everyone. Welcome to Flaky Test Management with Cypress. I'm Cecelia Martinez. We'll get started in just a minute, just letting a few people, more people join. We'll be using Slido today for our question and answer session. You can go to slide.do and event code is #Flaky. I'm gonna go ahead and just pop that information in the chat as well. Feel free to introduce yourself in the chat and let us know where you're from. Just make sure that you are sending to panelists and attendees if you're using the chat function in Zoom. All right. Looks like we have quite a few people from all over today. Wow, yeah, chat is busy. And again, we'll be using Slido today for questions, sli.do, event code #Flaky. All right, so let's go ahead and get started. So again, my name is Cecelia Martinez. I'm a technical account manager at Cypress. You can find me on Twitter at Cecelia Creates. What I do is I spend my days talking to Cypress users about their test suites, helping them get up and running with the Cypress Test Center and the Cypress dashboard, and also helping them overcome technical challenges. I'm joined today by Mike. Did you want to introduce yourself?
Yeah, Mike Cataldo. I am a DX engineer, so that's developer experience at Cypress, and working with you guys on how to be on being successful and working with the other teams internal with Cypress to make the product better. I live in Utah and love being here. Glad to be here.
Great, yeah. Oh, and I forgot to mention I'm in Atlanta, Georgia. So it's where Cypress is headquartered here in Atlanta. So again, so sharing kind of the slides in the chat, and then as well, we're going to be using slide.do for questions and polls today. So we are going to have a couple of polls. So make sure you get logged into Slido if you'd like to participate. All right. So the agenda today, we're going to talk about Flake, all about Flake. And I'm really excited to talk about this today because it's one of the topics that comes up the most often when I am engaging with our users. So we're going to dive into what actually is Flake, how we define it, some of the causes of Flake in your test suite, and how you can manage that as well. And then we're going to have some time at the end for a Q&A with myself and with Mike. And then again, if you could, if you're using Slido in order to ask questions, so if you do have any questions, please feel free to leverage Slido for that. If you have any technical issues or you can't hear me or my microphone goes out, then please feel free to drop that in the chat. We have a few moderators as well. And again, if you'd like to access these slides, they are public. They're at cypress.slides.com/Cecelia, that's me, /Flaky Test Management. So feel free to follow along or reference these, going forward as a resource. So we can go ahead and dive right in with what is Flake. So we're talking kind of a dictionary definition. We define a flaky test as when a test passes and fails across multiple retry attempts without any code changes. So for example, a test is executed and it fails. And then it's executed again, nothing else has changed, no test code has changed, the environment's the same, but this time it passes. So all of a sudden we have a test that is considered flaky because we don't necessarily know for sure if it's going to fail or pass deterministically. So let's take a look at an example. So the Cypress Real World app is our flagship demonstration app for Cypress use cases and best practices. It was built by our DX team, and it is a full stack React application. It's a Venmo style payment application that allows you to, it's again, it's an application that you run locally, but essentially allows you to send transactions back and forth to each other. You can comment on them, you can like them, very similar if you've ever used like Venmo or Cash App. And this is open source. We make all of our dashboard runs for the Real World app public, and you can access it at github.com/cypress.io, and then Cypress Real World app. And so one of the things that our DX team has done is they've added a branch with examples of flaky tests. So that is going to be the example that we're going to walk through today. And it comes directly from that branch on the GitHub repository. So our test case, like I said, this is a payment style application. So our test case for this flaky test is that user A likes a transaction on user B, and user B gets a notification that user A liked the transaction. I'm going to zero in on just a portion of this test to demonstrate. But in order to create a flaky test, in order to kind of force that demonstration, what we've done is we've just added a delay in our code for the likes API. So whenever a user likes a transaction, there is a random delay before the API responds and actually processes that like. So sometimes it can be, you know, a half of a second, it could be 5 seconds, it could be any number. So that is essentially how we are creating a flaky scenario. And again, this is a very real life situation as well. A lot of times we're not really sure how long an API call might take to respond. So our test case looks like this. It is a sci.contains, and we're grabbing the likes count selector, and then we're getting the like button and we're clicking it, and we're saying a successful like should disable the button and increment the number of likes. So again, if the default Cypress timeout is 4 seconds, and we have a arbitrary kind of delay set on our API, do we know if this test is going to pass or if it's going to fail? Well, if we run it, the answer is it depends, right? So if that delay takes less than 4 seconds, then the test passes. If we rerun the test and it takes 8 seconds, 10 seconds, then it's going to fail because we're not going to actually see that like notification come by in time. So what happens when you have a flaky test like this, when you have a test that you're not sure if it's going to pass or fail, and it has nothing to do with the actual application, it's just a flaky test. So flake can impact your test suite in a few different ways. It can cause longer deployment processes because you have to rerun tests or you have to restart CI builds if flake causes a failure in order to determine if it actually is an issue that you need to address before releasing. And then there's also can cause a longer debugging process. So if you get a failure and you have flake in your test suite, sometimes you have to, I've heard this a lot of times, people say we have to investigate if it's a real failure or not, or if it's just something to do with the machine being down or anything else that's going on. And then also it can cause reduced confidence in your test suite. So the main reason that we test, right, is to have confidence that our application is going to work the way that it needs to in order for our users to be able to engage with it. So if you have flake in your suite, then it brings up questions of, do failures actually represent regressions and bugs? Or on the other side, is flake hiding underlying issues in my application or test suite that I may not be aware of? And so these are all reasons, you know, and ways that flake can impact your test suite and can kind of hurt the overall health of it. So let's go ahead and start with our first poll. Again, we're at slide.do and the event code is Flaky. So let me go ahead and get this first poll going here. And we're going to start with the question of, how big of a problem is flake in your test suite? All right, so again, how big of a problem is flake in your test suite? I'll give a little bit of time here for people to answer. Okay,
While we're
so
waiting for the poll to come in, I wanted to make a comment here on confidence. You know, when you have flaky tests, and you know, in your test runs are part of your CI, you know, process, and you have, you know, all these, you know, test failures, and you're not sure if it's flaky or not. I think a lot of times you kind of get used to that constant failure, and eventually become kind of numb to it, and to a point where you don't know what to react to now, right? And so when there's a real failure, you're not doing anything about it because you just kind of chalk it up naturally to, oh, it's just flake, it's nothing wrong. And so yeah, it's just something that I've experienced and talked to other people about experience that they've experienced, and yeah, it's
Yeah.
a huge issue.
Yeah, it sounds like, based on these kind of poll responses, that it's a problem for a lot of the people here. And then also it looks like in the chat, I'm seeing some comments as well, kind of relating to that experience of you kind of giving up when you do have the flake and it's a persistent problem. So it looks like for, wow, almost 90% of the people here, it's at least, a moderate problem or they have some flake. Even more, almost 10%, it's a huge blocker. The 2% that are flake free, feel free to drop your tips in the chat if you have it, tell us
Yeah.
how you did it. Because I'm sure that would be very helpful. So hopefully you can still have a few things to learn today from the information. So yes, let's go ahead and move forward and talk about some causes of flake. And so I typically group causes of flake into 3 different categories. And these are categories that I identified by talking to our users over and over again about their test suite and what kind of flake they experience. So I'm gonna go ahead and stop the poll there. So the first type of flake that we see is DOM related flake. So this occurs when there's inconsistency with how elements are rendered to the DOM or how quickly they're rendered. So this can be a result of a couple of different things. It could be, I will talk about that kind of in just a second, but these are some of the errors that you might see if you have some DOM related flake. So you may see that a side out click failed because the element is disabled, and it probably shouldn't be disabled, but it's trying to click and it's not becoming enabled within that time frame sometimes versus other times. You also may see that it expected to find an element, but it didn't find it. That typically indicates that it hasn't been rendered to the DOM yet. And then also, errors about tests failing because an element is detached from a DOM. And so maybe you may have seen that one before as well. So some of the examples of DOM-related flake, we just kind of talked through a little bit of them, but if an element loads within the side.get timeout sometimes and other times it doesn't. So that was the example that we were looking at earlier, right? Now this could be because of instability in the DOM, it could be because of the API, but ultimately what's happening is the element is not always rendering within that 4 seconds. Additionally, like the first error we talked about, it goes to get an element, but when it tries to click it, it's disabled. Maybe there's another process that's happening with the state management and it hasn't updated yet that enabled that button within the time frame. This is a really common, well, it's not really common, but it's common enough that the DOM re-renders between a side.get and an action command. So this is where you'll see that detached from the DOM element. And it is because there's just a lot of re-renders happening with the application and it grabs the element, but then the time it goes to click on it, the page has re-rendered and that element doesn't really exist anymore. We see this a lot sometimes with drop downs, especially drop downs that have search fields. So for example, if you type in an input field, but the application is updating its state management with every key press event, it may not update in time, or the element may re-render and detach from the DOM while it's still processing that key press. So these are all examples of how DOM related instability can cause flake. And then there's network related flake. So this occurs when a network request responds inconsistently. And it can be an internal API, it can be your own backend, or it can be a third party, or if you have a serverless or microservices type architecture, or if you're hitting an integration endpoint for something like Stripe or your login provider, then you may experience flake because sometimes it responds, sometimes it doesn't. So this is where you may see errors, about too many elements being found because the response didn't come back properly to delete elements. You can have a timeout retrying for a wait. So side.wait has a default timeout of 5 seconds. And if a network request doesn't respond within that time period, then, you can experience a failure, even though it's not your actual application. It's, the staging API, or it's a third-party API. It's what you're trying to reach is inconsistent. So again, some examples, a slow API response results in a DOM element loading outside of the default timeout. That was the example that we used earlier, where because we were forcing that inconsistent delay, sometimes it did, sometimes it didn't. Additionally, like I said, a slow API response from a third-party login provider can cause tests to fail, especially if it's the first, if that's the first thing that happens, or it happens in a hook of some sort, that can cause a cascading issue where all the tests are failing. A microservices endpoint, I see this occurring more and more. It may have, if you have like a Lambda that you're hitting every once in a while, it may have a cold start or a start delay. So it fails the first time because it takes a while for it to respond initially. But then on subsequent attempts, it'll pass because it's now warmed up and it's ready to receive requests. And then finally, there's environment related flake. So this is flake that's specific to the way that you're running your tests. So it can be, for example, if you have inaccessible or inaccurate environment variables in your CI provider, if you are running tests across different size machines. So sometimes the test, the application will run slower and it'll cause failures. Other times it'll run quickly and it'll be fine. Other times it'll run too quickly and it'll run faster. Cypress will kind of run quicker than you expect, and you'll actually have some flake that way too. You could have a failed dependency install. So something goes wrong and the binary of your application just doesn't install properly, or something happens there. And then last but not least, if you have inconsistent data management across the environments that you're running tests on. So if you sometimes are hitting a staged environment, sometimes they're hitting a QA, sometimes a dev, or sometimes local, and you're using the user data that you're trying to access is only available on certain environments, then you can have flake. And again, none of this is related to your application. None of this is related to the way the tests are written. This is only as a result of how you're running the tests and the infrastructure that you're running on. And seen a lot of questions in the chat, so just to remind y'all, we're using Slido, so sli.do, and then #flaky is the event code. Thank you, Olivia, for posting that. Okay, so if we're taking a look at types of flake, go ahead and take a look here at the next poll, which is going to be what type of these types of flake, what type of flake do you most experience? And, we have DOM-related flake, network-related flake, environment-related flake, not sure, or a combination of all three. Definitely talk to people sometimes that experience that across the board, all different types of flake. So anything that you wanted to add there, Mike, on those different types that you've seen out in the wild?
I would probably say that DOM-related flake is a top one for me, but network-related flake, I think, has been something that a lot of people struggle with, that they really have a hard time getting around. You can put in, weights and things like that to try to circumvent it, but the fact that Cypress allows you full control over network and stubbing and things like that, and waiting on requests specifically, that's why this is for you Cypress users, maybe that's why network related flake is so low, because Cypress does a great job at eliminating that.
Yeah, and it's something I like what you said is about how sometimes there's just not really a way around it, because that's one of the things that's a trend too with people that I talk to, is that with environment related flake, right? Sometimes you just don't have any options. You're tied to a certain CI provider or a certain number of machines or certain kind of resource constraints. And a lot of times too, there's issues with the underlying application, right? So if you have a slow staging API or a slow QA API, that may be something you can't really get around. And so those are things that flake is typically, if it's DOM related specifically or network related, it's an indicator of underlying causes. And sometimes you can't fix the underlying cause. So what we talk about is ways that you can get around it, ways that you can approach it from the test writing perspective. So yes, looks like almost half say the DOM related flake is the most common for them. So that tracks kind of what we were talking about. But it looks like quite a few of you, almost a quarter, are experiencing all three, or a combination of all three. So let's take a look about how to kind of tackle some of these. So I'm just gonna switch that and I'm gonna go ahead and turn off the poll. And it looks like we have quite a few questions as well. So make sure that you get those in. We're gonna be doing a Q&A at the end here. So, all right, so let's talk about managing flake. Let's see, there we go. So we'll start with DOM-related flake because that was one of the most common ones that y'all said. And then it's also one of the most common ones that we see. It also tends to be one that can be a little bit harder to diagnose, especially if it's the result of underlying issues in the application and you're not able to, make changes to the source code if you're kind of just stuck with the application that you're given, right? So there's a couple of ways that we can approach this. First thing I want to do is talk a little bit about how query command retryability works with Cypress. So with the Cypress syntax, this is an example of kind of just a very simple test. It is a to-do application. We're adding 2 items. So we're getting the new to-do input field. We're typing to-do A, hitting enter, typing to-do B, hitting enter. And we're saying that the to-do list items, there should be 2 of them. So probably seen this test if you've ever done our Cypress testing workshop repository, or if you've kind of been in our docs, we use this example quite a bit. So let's kind of talk about this section here. So sci.get, and we're saying that the to-do list, the list item element, there should have a length of 2. So there should be 2 list items. Now, a couple of things can happen. If the assertion that follows the sci.get command passes, then the command finishes successfully. So if we get the to-do list and the list items and it has a length of 2, meaning that both of those to-do items that we added are on the page, then it'll pass. If the assertion that follows the sci.get command fails, then the sci.get command will re-query the DOM again and again until the assertion passes. So this is one of the really powerful things about Cypress that makes it such a good tool for combating flake. Say if we go back to think about our original test, we type to do enter A, to do enter B. I mentioned before that if you have an application that processes, each key press and it updates the state, it may take some time to actually see that re-render in the DOM, especially if your application is running slowly, if you're in a slow environment. So if you were to go ahead and grab that to-do list and only 1 list item was on there, and then proceed with the test, it may have a length of 0 or a length of 1, and that assertion is always going to fail. What Cypress does is it continues again to re-query the DOM. It gets that element over and over and over again until it passes up to the default timeout of 4 seconds. So just by understanding how that retryability works in the command level, you can see how that can reduce a lot of the instability that you have with the DOM. So again, on this example here, we can see in the GIF that's playing that for a period of time, if there's a delay, the assertion is actually failing, right? It's expected to have length of 2, but got 0. But because of that built-in retryability, it keeps requerying the DOM for up to that 4 seconds, and then ultimately it does pass. So that would have been a test that failed, but because of retryability, it actually passed. So how can we use this information in order to write to write tests that are more resistant to DOM-related flake? One thing to keep in mind is that only the last query command is retried. So what we recommend is using a single query command instead of chaining. So you may see something kind of like, sci.get a selector. So let's say h1 dot contains and then text. In this situation, if you had an assertion after it, only the dot contains is going to be retried. Same thing with that second example, sci.get selector. If you use a .its, only the .its is going to get retried. That initial .get will not be retried in this type of syntax use. So if you get an H1 and then the DOM refreshes, or then it updates, you're always going to have that initial H1, and it's going to fail. Instead, what you can do is leverage sci.contains, which allows you to pass through the text and a selector, or you can essentially do sci.get and then you can pass through a regular expression or something very specific, so you don't have to chain the queries. And so in this case, if you were to do sci.contains selector, comma, and then the text, the entire query is going to retry. So it's going to keep pinging the DOM until it finds the element that contains the text, and both of those are true. The other thing that you can do is you can alternate commands and assertions. So for example, in this case, we have sci.get a selector, and we're immediately chaining a dot should on there. So we're saying dot should have length of 3. Again, that dot get is going to retry until that assertion passes. And then so if we had something where we're making sure that it has all 3, and then we're going to go get the parent, now we know that we have the correct element before proceeding. So if we were to get that selector and it had a length of 2, and then so we know that it's not the correct one, then we went to grab the parent. Again, the dot should is going to link to the parent, so only that parent's going to retry. So by alternating commands and assertions in this way, you can ensure that you have the correct element on the DOM before proceeding with the next command in the test. Now, this is a general best practice, but you can also think about it in the areas that you're seeing flake in your test suite. We have an entire kind of series of blog posts about flake, but you want to keep in mind that essentially you have to think about what state does the DOM need to be in before I can proceed with the action. And if you think about it, you want to think about it like a user, right? So if a user is typing in a username, a password, and then a submit button, if they type in their username and they type in their password, and halfway through the password, it freezes, and they notice that it hasn't filled out yet, they're not going to hit submit until they see that everything has loaded, right? So you could have an assertion on those input fields saying that the value is a certain value before you proceed. That will ensure that everything is settled the way that it's supposed to be before you proceed with the test. So just think about writing your test the same way that a user would interact with your application. And then, as I mentioned, we have an entire series of blog posts related to Flake. It's just cypress.io/blog/tag/Flake. I also wanted to point out this really great webinar that we had a while back about using code smells to fix flaky tests in Cypress. So as I mentioned, a lot of times DOM-related instability is the result of your underlying application. So you can take those flaky tests and you can learn from them. And so Josh Justice and Gleb Bamatov in this webinar go through some of the causes of DOM instability, specific examples, and how those are addressed specifically. So definitely recommend checking that out, as well as the blog posts if you have additional examples of how to wait for the right state before moving forward. All right, so let's talk about network-related flake. So as I mentioned before, network-related flake is when you have an API or any kind of network requests that are inconsistent. There's a couple of test writing best practices that we'll talk about. They're both going to be leveraging spy.intercept. So with spy.intercept, you can spy and stub all network requests. If you've been using Cypress for a while, you may know it as no-spy.route, which was the previous iteration of this. Spy.intercept allows you to intercept all network traffic and can be very powerful with how you handle both requests and responses. So there's a lot of things that you do with spy.intercept. I'm going to talk specifically about how you can leverage it for network-related flake. So the first thing you can do is you can wait for long network requests before proceeding. So if you know, for example, that there's a certain API response that's just has a really complex query, or you just know that that takes a long time, you can intercept that request. You can essentially spy on it, and then you can set up a wait. So in this code example here, we're setting up an intercept for get requests to our API endpoint, and we're saving that as the variable get account. Then we're going to go ahead and visit our page. What we have on line 5 is we are saying, please wait for this request to go through. And instead of the usual 5 seconds, you can wait up to 30 seconds because I know that it may take a while. Now, it's not going to wait the full 30 seconds if it doesn't have to. It's going to wait up to 30 seconds. And so this is very powerful because it essentially says, for certain routes that you know may be slow, take as much time as you need, or take more time. Maybe you don't set it to 3 minutes, and you just get a new API or something at that point. But it essentially says, make sure that this request has completed before proceeding. Because again, if you go to get the selector and it should have text account name, that's going to default timeout after 4 seconds. Now, maybe wondering why increase the timeout on the network request wait and not just increase the timeout on the DOM selection. So if pinging the DOM is more expensive from a resources standpoint, right? So if you're waiting for a network request and you know it could take 20 seconds and you have a 30-second timeout, you can be waiting for the network request for 20 seconds and then you have the DOM proceeding. Whereas if you're pinging the DOM over and over and over again for 30 seconds, you know, that's not as efficient of a test run. So by waiting for the network request first, you know that all of that has been completed before you proceed with going ahead and querying the DOM. And I've seen some very long timeouts. So actually, I'm kind of curious if y'all can pop in the chat, like what the longest default timeout is in your test suite, as I've seen some very long ones. So one of the other ways that you can use site.intercept is you can stub inconsistent network requests to control the response. So in this case, we are actually not just spying on the request and on the route, we're actually stubbing it. We're saying, hey, no matter what happens in real life with this request, we're going to say that it was successful and we're going to tell our application it was successful. So if you normally go out to a third party to process your payments, for example, you probably don't want to really do that in a test environment. You don't want to actually process payments. And then not only just because you don't want to process payments, but because it could be inconsistent. And that's also not really a result of your application test. That's the result of the third party. So you can say, hey, whenever we're going to this inconsistent URL, go ahead and just send back a success response. Just, you know, tell the application everything is good to go, and you're essentially tricking your app into moving forward. So if you have inconsistent URLs, if you have certain endpoints that are always problematic for you, you can just stub the response and mock it out that way instead. I did want to comment on an additional thing that I've seen, and that addresses the cold start problem. It's not kind of covered here, but if you do have, you know, things that have a cold start, I've seen people leverage CI, their CI pipeline, in order to make a request to the API to start it up before starting the test. That's kind of a different way that I've seen people approach that specific issue. If you have an API endpoint that you know is going to need some time, it would make sense to start that earlier in the CI process rather than doing it in the middle of a test run if you can. So
I think the top one that I've seen so far is maybe 300 seconds.
nice.
I think mine was maybe 90 or 100. So one of the situations that I ran into was a test environment that I was using wasn't being cleaned up. So we would be running tests to say like create a user. And so the user base on, you know, on the database of users was getting into the thousands. And so there were some tests where it would actually query for all of the users, and it would just take forever. And so I would have to use this approach to get around it. But really the response to that wasn't, you know, pertinent to the to the test. And so I probably could have just stubbed that out and just responded with, you know, some fake data to get around that. But yeah.
Yeah, just like Chuck just said in the chat, you should be cleaning up the data, not increasing the weight, right?
Yep,
and that's yeah,
right.
and that's absolutely. So test data management is another one of the kind of the top topics that I talk to people about. But another thing to keep in mind too is when the nice thing about site.intercept, you know, you can pass through a fixture file. So if you have static data, you can leverage the Cypress fixtures folder and just have a bunch of fixture files or JSON, however you like to do it. And you can pass that through as the second option. You can also do a callback function. So if you needed to do something more specific with whatever the response is, you can also, you know, get certain information from the response and the request body, and you can leverage that in the stub if you needed to. So again, a lot of different options inside of Intercept. Definitely recommend checking out the docs. There's a lot of examples. This site.intercept on the slides is a link to the API page there. So. And then, so we talked about DOM related instability, we talked about network instability. Now I want to talk about some ways that you can kind of combat all types of flake. So the first that I want to talk about is test retries. So test retries is a Cypress test runner feature that will retry an individual test a specified number of times before failing. Now you can configure test retries on a global level. So it will say, every single test that runs in our test suite, I want you to retry it a certain number of times. You can also specify the configuration at the at block level. So you can say this test only, rerun it, retry it, or this spec only, in this describe block or this context block. Then I want to reset the I want you to retry this spec because we know it's specifically flaky. I would recommend enabling test retries globally unless there's just a very specific strategy that you have in place where you only want to retry it in certain areas. So in order to turn on Cypress test retries, you do have to be on version 5.0 or higher. And in your Cypress.json configuration file, the absolute easiest way to do it is just set retries and then the number of times that you want it to retry. So this will say it'll retry up to 1 time or 3 times or 5 times. I've seen all kinds of numbers. Everyone's test suites are different. And then you can also configure it by mode. So again, in the Cypress.json, you can set it to retry a certain number of times when you're running Cypress run versus executing Cypress open mode. And what retries does is it'll, when you're using the Cypress dashboard, so like I said, not only does it retry the test and it'll show in the output that it made multiple attempts, and then on the 3rd attempt, it finally passed. In the Cypress dashboard, you can also see the artifacts from the attempts. So on the right-hand side, I just have a screenshot of showing, on attempt 1, it failed. Attempt 2, it failed. And so we have the artifacts, the screenshots, the video of the entire run from those attempts, those multiple attempts that took place. So
I wanted to chime in.
Yeah.
Real fast. So if you can head over to the documentation on configuration for more details on this, but what you could do is you could actually set a local setting for retries. So if say you're using Cypress on your local machine and you don't want retries or you want more retries or something, like in open mode, for example, you can do that and it'll override what you have set for for CI, and that's just something that's local that you don't commit to that you don't commit to your version control. That's just something that I've done that can be helpful.
Yeah, that's a really great tip, and that's also allows you to if you have different like preferences across different developers, right? And that's not checking the source control, so everyone can kind of have their own control there. Looks like in the chat people are saying usually 2, 3, 1, 1, 2, 3 typically tends to be some of the more popular responses for how many retries that they have turned on. And again, this can be helpful for all types of flake. So if you have DOM-related instability and it misses it by 1 second, maybe the second time it's faster. If you have the cold start API and it takes 10 seconds and so it times out the first time, the second time it's fine, test retries will help with this. If you have something that goes wrong in your, with pulling in the environment variable or something with the environment where your staging environment is just really slow and it's starting to have issues, the retries can help accommodate that. So it's essentially a really powerful all-in-one kind of or a blanket approach. I call it a horizontal approach because it affects all 3 categories of flake by enabling test retries. And again, you do have to be on version 5.0 or higher. So when you have retries enabled, if you are also using the Cypress dashboard, so the Cypress test runner is our free open source test runner. We also have a Cypress dashboard, which is essentially our dashboard product that it builds on top of the test runner and records all their tests to a decentralized location where you can review them. So if you have test retries enabled, what the Cypress dashboard does is it identifies flaky tests and flake severity based on the number of times a test is retried. So a test becomes flaky if it fails, but then on a subsequent attempt, passes. And so, like I said, test retries must be enabled in order to be able to see flake detection in the dashboard, but it allows you to see artifacts from failed attempts on flaky runs. So that's image I just showed that has the multiple attempts and it shows the screenshots from those. But the nice part is you also get flaky test analytics. So we'll show you the common flaky tests amongst your test suite, most common errors, historical rates, and then also the test definition cases. So just to kind of give you an idea of what that looks like, we'll come to this tab here. So this is the Flaky test for the Cypress real world app. So as I mentioned, our Cypress real world app is open source. We make all of our dashboard runs public. So that's what we're looking at right now. And we've added specifically some Flaky tests to demonstrate. So we can see here that 20% of our test cases are flaky, not great. Again, we've added some in purposefully, but we can also see that the majority of them have a low severity. So again, severity is based on how often the test is flaky. So our highest severity flake was flaky 38 out of the last 74 runs, and it was last flaky 5 days ago. But if we click on this individual test case, we can see the runs that it was flaky from. We can see the most common errors. So we can see that the times that it was flaky, we got this assertion error 47 times, that it timed out retrying defined content appreciated. So that gives you some like immediate insight that, you know what, this always has the same error. Because sometimes you may look at a transaction and it may have multiple types of common errors. And in that case, like for example, this flaky test case has 4 different types of assertion errors. So that may indicate a different type of problem. Maybe that's something more related to the network or the environment versus one specific DOM element that could be flaky. Again, you also do have the flake rate. So you can see historical information, and you can also see the test code. The other thing that you can do with this information is with the dashboard JIRA integration, you can create a JIRA ticket directly from a flaky test. So this allows you to not just kind of say, all right, it was flaky, but it passed eventually. We'll just move on with our lives. You can actually, quarantine and address these flaky tests before they cause more and more issues in your test suite and start to build up. And also by getting a sense of what some of the most common errors are and having that bird's eye view, you're able to maybe see trends and say, hey, you know what, like this API endpoint is causing a lot of problems. Maybe we should just dedicate some time and clear out that technical debt, right? So that's a way that you can use the flake detection with the test retries with the dashboard.
This is huge because and I don't know about you guys, but a lot of times I'll be working on a test and the test itself is flaky, but it's a whole different ballgame when it's not actually your test that's flaky. You're running the whole suite, locally, and it's a totally different test, and maybe you don't want to take the time to go addressing another test. You're working on something else. And so this is great because then it allows you to see that flakiness, to have it record. It's in the history, and you can create a task to have it, to be accountable for it, to taking care of it at a later time, so that you don't have to be constantly playing whack-a-mole with your flaky tests.
That is the perfect way to describe it. It's playing whack-a-mole. And so, yeah, definitely want to avoid that. Save it for the carnival. And then I also want to talk a little bit about some of the features that we have around flake management. So with the dashboard as well, you do have GitHub and Slack flake alerts. So you will post back to the GitHub pull request a comment specifying what tests were flaky and a link directly to the flaky test. Same thing with our Slack integration. We'll post back to a Slack channel and say, hey, you got some flake. So you could even have a dedicated flaky test channel that you're leveraging the Slack alerts for. And then I also wanted to talk about a new feature we have coming out called Test Burn-In. So this is going to be a new flake management feature in addition to the flake detection that will actually identify if new tests are flaky before introducing them to your test suite, before kind of making them a regular test. So what it will do is it'll identify that a test is new. First of all, it'll say, hey, this is a brand new test case. We haven't seen this before. And then it'll automatically retry the test multiple times, a configurable amount. So you can do it 5 times, 10 times, however many times that you'd like to set it for, to check for flake. Because again, flake is when a test fails, but then passes. And so if you run the test once and it passes, you don't necessarily know that that's not a flaky test until you run it multiple times over and over again in your suite, and then you start to see failures. So it kind of allows you to, battle test, so to speak, your tests as soon as you bring them in, as soon as you write them and introduce them to your test suite. So it's easier to fix early before it becomes an issue, before you see, you know what, like I'm seeing this test fail sometimes and seeing it starting to pop up in our flaky test analytics. This allows you to just know right off the bat, hey, this test, we ran it 15 times and it passed all 15 times. This is not a flaky test. In the future, if it fails, it is a real failure. Pay attention to it. So again, just something that's going to help increase that confidence overall in your test suite.
I'm excited about that because there have been times when I'll run through my tests and just like, I hope it passes, this is one of those things where, it'll really give you that confidence. Like you don't have to, assume, okay, it ran through, it's fine, everything's good, we're good to go. Like this is gonna, really battle test it so that, you're like we're saying that, addressing it sooner rather than later.
Yeah, absolutely. It looks like a couple people in the chat are excited for it as well. So yeah, so keep an eye out for that. Okay, so let's go ahead and take a look at our next poll. Looks like I need to just kind of turn it on here. So next poll is going to be, which of the flake strategies that we talked about will be most helpful for your test suite? And you can choose multiple ones, just trying to get a sense of what some of the things that we talked about, what was helpful for you, what are you looking to kind of introduce to your test suite. And right after this, we're going to go ahead and kick off the Q&A. So, last chance to get your questions in at slide.do, event code Flaky. And just so you know, too, we will also be sharing the link to these slides. So I did see a comment about the screenshots. Thank you for pointing that out. Definitely will keep that in mind for the future. But if you want to visit the slides, you can feel free to view any of those images as well. Okay, nice. Mike checked every box. I love that. Okay, good comment. Okay. Yeah, so it looks like definitely alternating commands and assertions is a popular one. Absolutely a best practice. Definitely recommend getting in the habit of doing that. It can solve a lot of issues with DOM-related flakes specifically. It's like about half of people are interested in using site.intercept for network calls, whether that be intercepting and waiting for them or stubbing them. And it looks like, yeah, a lot of people also interested in test retries, and then around 30% for flake analytics and test burn-in. So yeah, it looks like that test burn-in is going to be popular, Mike, once it releases. All right, awesome. So again, let's go ahead and I'll go ahead and close this poll out, and we'll answer some questions. So again, I'm Cecelia Martinez. I'm technical account manager at Cypress, and joined by Mike, who's a DX engineer on our DX team. And so we'll go ahead and see what questions that y'all have. Now, again, in Slido, you can also upvote questions. So if you see one that you, oops, let me go ahead and turn the poll off still, there it goes. If you see one that also pertains to you, please thumbs up it so we can know which questions are people are most interested in getting answered.
I can take this first one here.
Yeah, great.
It says, I have flakiness 5% of the time because of slow response from outside API we're using for part of our app. How do you deal with such cases? And it looks like this is at the top of the list, and it is a common problem. And what I would recommend is stubbing that if you can. If I'm trying to think of it like an example of an external service. What's a good example of an external service? And maybe I can.
Yeah, typically I see, payment services is a big one, using PayPal or Stripe integrations. Also, sometimes just to get like maps, sometimes they get like data like that if you're hitting an external API in order to get like Google Maps information or anything if it's not actually built into the application. I've seen issues with those as well.
Yeah. So like if in the case of, say, with a payment, if really you're just waiting, if the most important part is, before you can continue on, is the status of that payment, rather than, wait for, PayPal to respond to you, you can actually, with site.intercept, just return a fake response that includes, that status, or even not. You can even stub a bad status and test that as well. And then you don't have to worry about any of the, gymnastics involved in trying to get it to fail. You have full control, even if it's not your third-party API. Yeah, that's what I would suggest.
Yeah,
I don't know,
absolutely.
Celia, you have some.
I agree. That's definitely what we recommend in most cases. Yeah, absolutely. We're going to talk about the next one about flakiness in the before and after hooks, please. So this is a really good question, something to point out, is because if something fails in a before each hook, it will go ahead and it'll fail the run. And this is because obviously if something fails in a before each hook, it's going to fail before each test, right? And so what you want to understand is essentially is why you're experiencing flakiness in that hook and what you're using that hook for. So a lot of times I see people use hooks to set up test data, right? So maybe they're hitting an API endpoint and they're using that to set something up, to set up the state for the test, so to speak. So yeah, I don't know if Mike, if you have any specific approaches to this, but typically understanding what's causing the flakiness in the hooks and then making sure that you're using the hooks correctly and you're leveraging it in the right as the way it's intended to be used.
Yeah, I agree. I think I'm hopefully I can, we're answering this, but yeah, if you don't want the whole suite to fail as a result, because that's an advantage, I think, is having the whole suite fail, because you don't want to continue on and then have something else be broken because that prerequisite hasn't been met. So if it's not necessarily a prerequisite, the thing that's failing, then you might want to put that in the test. That's my best answer there.
Yeah, I agree. If you have a failure in a before each hook, it makes sense that it would, set up the entire run. There are certain things that you can do to tap into certain types of events, like, on before, like a test failure to, if it's a certain error type, things like that. But in most cases, I would say, think about what the use case is and whether having it in the hook makes sense versus in the test. So.
Yeah, I always err on the side of putting things in a hook if I feel like it's not necessarily part of the test. It's, like I was saying before, like a prerequisite of that. That way it really helps delineate between the test and what's required for setup, but it also takes advantage of that how hooks work and how it fails the whole thing.
Awesome. Yeah, just a reminder, y'all can upvote questions so that they pop to the top if you see any that you like. And then also make sure that you're using Slido for questions and not the chat. So this next one here, flaky test because an element won't load the first time. In my opinion, I would test retries, would handle that situation. Also, if it's not loading the first time, that may be an application issue. So maybe I would definitely want to check that out. But a test retry would, like automatic retries, that would address that issue specifically. And then how to handle flakiness in iframes. Do you want to talk about our iframe roadmap, Mike, at all? Or I know that they added some additional support there to test runner roadmap.
I'm not sure.
Okay, yeah, so as far as flakiness in iframes, again, retries is going to help here. That's if you have an issue the first time. I did also want to, basically, I was kind of hinting at it, was we've added iframes, like full iframe support to our roadmap for the Cypress test runner. So keep an eye out for the issue. On our roadmap, we show both the GitHub issue that we're tracking, as well as if the pull request has been submitted. So you can always kind of check that for the latest updates on support for those new features.
Yeah, and if there's something specific, feel free to reach out to us. Maybe we can put something in the last slide. Information on how to get in touch with us.
Yeah, that's a good question. Yeah, that's a good point. So the next question here: can we increase the timeout in every increment in retries? Wow, I haven't seen that before. So typically it sounds like what you're saying is if it's on retry number 2, then please increase the timeout to 60 seconds. I know that there is if you can leverage the module API with Cypress in order to count the number of attempts. So there's you could probably code it where you're saying if attempt 2, then reset the Cypress config default timeout value to 60 instead of 30. But it would require some customization. So
there's probably a global, I'm sure there's something in the global context that states which retry we're on. But I'd have to think about that one. It's an interesting question. I actually like that. And if there's, if there's enough demand for it, we might be able to come up with something that that everyone can, can take advantage of. But yeah, I'll have to think about that one. That's an interesting question. One actually somewhat related to this that, in case you guys don't know, is you can actually increase retries at a per suite or test level, just by adding another argument. It's the, what is it? I believe it's the second argument to an it or a describe. It just, you just add retries in an object, and you can set it to whatever you want, and it will just apply to that test or suite.
Nice, thanks. Yeah. So I'm kind of looking at some of the other questions here. How do you manage inherently flaky tests depending on third parties without sacrificing confidence by mocking? So I've seen this a lot. And so, if a test is inherently flaky because it's dependent on a third-party API, you want to think about what it is that the purpose of what you're testing. So if you're testing your UI, right, and you want to make sure that your UI doesn't have any regressions because you pushed code, does the UI test really need to test that third-party API? Versus if you're doing an end-to-end, full end-to-end test, or if you're doing, like contract testing, where you're actually specifically making requests to a third party to test it, that may be, those may be better applications than using a third-party API in your UI test, because really the purpose of the UI test is to test your UI. And then as far as so Mike, I don't know how you feel about that, if you agree with that kind of approach.
Yeah, I have an idea. So one thing that you could, because I've always erred on the side of pure end-to-end, in that I won't mock anything out, but obviously, and that was just based on my own circumstances in the teams that I've been on in the past. But one approach that you could take is by having actually two versions of the test. One where it's mocking that you could run most of the time, and then have another one that actually hits that real back end. And that way it kind of gives you a little bit of both. And because I can understand how, if you're mocking a third-party service, and then that third-party service changes, but you don't update your mock, now you're going to have some problems when you go live with that. So I think that if you have a another true end-to-end that hits that back-end service, or perhaps another test that just ensures that your contract with that third party is right, that you're making the right assumptions on that third party service, that could be a way to go.
Yeah, that's great. Yeah, thank you. So we are coming up towards the end of the hour, so I'm going to I want to answer one more question. It's another one that got a lot of upvotes, just in it specifically around flakiness versus the .click question, which is kind of different. But my team is experiencing increased flakiness the more we scale our test code. What's the likely causes? So I have some ideas, but I'll let you go first, Mike.
I mean, I don't know what that scale looks like, but maybe if the flakiness is increasing because the test sizes, the spec sizes are increasing, it could be happening as you scale, because like what I experienced before, where it was environmental. Those are the only guesses that I have.
Those are the top two that I see, honestly. So first one you said is that the test, once spec files become really long. So if you have, I would say, maybe it kind of depends. Like long is a little bit arbitrary, because it depends on how long it's taking to run. But the more and more if blocks that you have in a spec, right, the more tests you have in a single spec file, you could over time start to see that those tests start to run slower, which means that you're probably having performance issues. So the application may be running slower, or it may start crashing halfway through. and that's going to cause flake. To that point as well, if you have infrastructure issues on the machines that you're testing. So as the test suite starts to scale, it's the resources on the machine aren't enough to actually run your application and the tests and Cypress. You might need to like bump those up to prevent crashing or prevent flakiness there. The other thing that it could be as well is that I've seen is if you, depending on what kind of abstractions that you're using in your test code. So if you're using custom commands or utility functions or selectors that are getting harder and harder to maintain, or if you have some things that are hard coded into your tests and a lot of changes are happening on the code side that could be breaking things. Definitely worth taking a big picture look and saying, hey, how are our tests organized? You know, how are we splitting up our spec files? How are we leveraging abstractions? How are we leveraging what I like to call the low-hanging fruit, which is things that you're doing in the UI in your test that you don't actually need to do. Logging in is a big one. So if you're logging in via the UI for every single test, that's inefficient. And over time, once the more and more tests that you have, the more resources that's going to use in your application. If you're only logging in because you just need to set up state for your test, you can do that programmatically, either using API, using your front-end state management tool if you're using one. So in the Cypress Real World app, we have 3 login commands. We have login by UI, login by API, and login by XState, and we leverage them throughout our test suite in order to be efficient when we can, and that speeds up the test run, prevents performance issues over time as this test suite gets bigger. So awesome. So all right, so we are out of time. Thank you all so much for the great questions, great comments, so much participation today. We will be taking a look at all the questions do get saved in Slido. So I'll be taking a look at some of them and kind of answering some of them on Twitter. So again, if you'd like to follow us, I am at Cecelia Creates on Twitter, and Mike is MC Cataldo on Twitter. Yeah, there's 2 C's there. I got to keep that in mind. And then also, feel free to reach out to us. We are at Cypress, hello@cypress.io is kind of our general email address, but we're also on Gitter and we're also on Discord, and you can get both of those links in the documentation as well. So thank you all so much.
Definitely recommend Discord. Reach out to us there, and yeah, stay active in the community. We're here for you.
Yeah, and Cypress is what it is because of the community, because of all this great participation, because of our open source contributors. And so definitely please keep giving us feedback, giving us questions. We're here to help. So oh yeah, people are asking for the Discord link. So let me just see if I can grab that really quick for y'all.
Matt got it for us. Thanks, Matt.
Oh, awesome. Thank you. Thanks, Matt. Great. Awesome. Well, thank you so much, everyone, for the time, and have a great day.
See you later.
Bye.